All right, welcome to our final video on brightness. This is video number 5, talking about calibration points with these guys. So we've defined what brightness is, the methods we use for making the brightness measurements. As a company, every instrument we manufacture meets a specific paper industry standard, whether it's a TAPPI or ISO method. And so we put a lot of time, effort, and research into that. You make a big investment to purchase one of those pieces of equipment. So if you've gone through the purchasing process and you've gone through the justification of why I need a TAPPI or ISO instrument, the important thing is to be able to keep that instrument maintained and calibrated properly so that it generates a TAPPI number or it generates an ISO number over time. Well, how do we go about doing that? Once we have an instrument that's standardized in its manufacture, we've got to be able to maintain that calibration with that. So we do that through calibration programs. And in my experience, I've worked in other color markets, and nobody pays attention to calibration the way we do in the paper industry. Our goal as an industry is that no matter where I make this product, if I'm making it to a particular standard and those instruments are properly calibrated, I'll be able to reproduce that number wherever I ship this product, as long as, again, I'm measuring it on a like manufacturing, like calibrated instrument. So we've got two methods for going about doing that. For the TAPPI world, Tech9 Laboratory Services here in New Albany, Indiana, we are the home for the calibration for the TAPPI brightness method. So back in our master's laboratory, we have a master TAPPI instruments. So there you'll have a master instrument. And we have two of those that generate calibration standards. So those two are always brought together, make sure they're agreeing perfectly with one another. And then what we do then is we have a stack of calibration standards in different ranges of brightness so that you can do a primary calibration and then verify your linearity of calibration across a wide range. So these paper standards are then evaluated on the master instrument. And then the value, let's say for this sample, reads 93. So then that value is recorded to read 93 for that sample. Then I take that standard and I bring it to my instrument and I go through the calibration sequence on that instrument and I say read 93 for this sample. And then what that does is that forces this instrument back to agreement with the master instrument. And so if we are sending out samples to the industry from this master instrument, all reading similar paper, then we take those calibration papers onto our instruments. We're now bringing that calibration to this instrument. So that gives us reproducibility from one instrument to another. That's one piece of it. The second piece of it is repeatability, so that, you know what, if this reads 93 today, it's going to read 93 tomorrow, next month, next quarter, next year. So it's our job in maintaining the master laboratory instruments is to make sure that this point does not drift. So we have a lot of checks and balances in our processes to make sure that we have an anchor at that point for calibration. So the host sequence in the TAPPI method is pretty simple. It's to bring instruments into agreement with a master instrument back in our master's laboratory. The ISO world is a little bit more involved than what we have here with the TAPPI method. In the ISO world, there's a hierarchy of calibration. And for the sake of conversation and to make it maybe easy to visualize, we're going to draw a pyramid. Okay, so we've got a pyramid here, and there are 3 levels of calibration in the ISO world. So we're going to take this, we're going to break it into 3 levels. We're going to call this IR1, we'll call this IR2, and then IR3. So those 3 levels there. For us, we're going to take IR1 and IR2, and we're going to give that to NRC, which is National Research Corporation up in Canada. And what the folks there do is they maintain the master calibration point. All right, so we've got that. They then, through the ISO standardizing group, work with them to verify laboratories that they can transfer calibration standards to. And there are currently 4 authorized laboratories in the world for producing ISO calibration, optical calibration standards. There is the Tech9 Laboratory Services here. There are and 2 other in Europe, and FP Innovations up in Canada. And so what NRC does is they transfer calibration to the 4 NRC, IR level 3 laboratories, the authorized laboratories, and then we take our ISO conforming instruments, we bring those calibration standards in, calibrate those instruments, much like we do here now, and then from there we generate the calibration standards, we send out into the industry. So these guys share calibration standards on a regular basis. So on a monthly basis, we're sharing calibration standards with one another to make sure that repeatability continues, that we can manage the repeatability with that by making sure no one is drifting off and not generating the proper calibration standards. How we calibrate, whether it's the TAPPI method or the ISO, we calibrate them the same way through master instruments. How we maintain those master instruments is difference between one method and the other. But the end game is that we're able to provide you a repeatable and reproducible standard on a monthly basis, so that if you're an organization that has customers in different parts of the world or sister mills in different parts of the world that are making the same product, and you want to make sure that your customer, whether they get product from mill A, B, or C, are getting the same thing, well, the calibration program helps us to accomplish that. You buy standardized instrumentation, you keep them standardized with good calibration tools, you've got a very good chance of being able to accomplish just that. Now, so the calibration sequence is a little bit different. Also, the calibration points are different between the two methods. The TAPPI method started out with and continues to be calibrated to magnesium oxide. So magnesium oxide is a 100% point for the TAPPI method. So when we say something has a brightness of 96.3, that's 96.3% as bright as magnesium oxide. Okay? The ISO world started with that same methodology where they were calibrated to the magnesium oxide, but after a period of time they decided that, all right, that wasn't an adequate calibration point. So there is a fairly complicated technical procedure you can go through which will generate a value called absolute reflectance, which is a perfect white basically. And that's one of the tasks of the IR level 1 laboratory, is to manage and maintain that point. So what that did when they did that is that elevated the scale by 1.5 points or thereabouts. So the ISO scale went from here to here. So now the two instruments have a different photometry, and that their calibration points are different between one another. So the two methods today, you've got the differences we've talked about already. The geometric differences are there. The photometric differences that come in via the calibration point, and then the spectral response, again, is the same between the two. All right, so it's very important that calibration becomes part of your regular routine program. Paper standards are what we use because paper is what we make, and we don't want to use a transfer standard different from what we make. So because it's paper, it has a life to it. It's going to fade. It's going to change a little bit with moisture content, whatever it might be. So those paper standards come with a defined length of use. But what we have found is that if you will take those paper standards and put them back into the black envelope they come in, that's going to block light, and if you put those into a desk drawer, that's going to help those maintain their life for a longer period of time. In theory, they're a one-use product. Well, in reality, we know that you use them more than once, and that's perfectly fine. But if they do get soiled, if they do get bent, if they do get scratched, whatever it might be, the values then change on that standard, and you need to get new standards. Most customers get fresh standards on a monthly basis. Some choose quarterly, but minimally a quarterly calibration is about as far as you want to go out, because a lot of things can happen in a month. And you think about the cost of a calibration standard, and you compare that to the cost of culling a reel of paper, and the two outweigh, that cost of reject far outweighs the cost of a calibration standard. So sometimes you may have a hard time trying to justify in a maintenance budget a calibration standard, but compare that to a production cost of not meeting a customer spec or shipping a product that isn't what the customer wanted because your instrument wasn't calibrated properly, because your calibration standards rolled, and you'll quickly pay for that calibration tool. So calibration is important. But the first step is standardized instrumentation. And the two methods we've talked about so far, again, are probably the two most common tests made in the industry today, and that is either ISO or TAPPI brightness. Again, we estimate that our instruments have probably made over 200 million tests over the last 45 years out in the global pulp and paper marketplace. And you bring in some of the other competitive products, and we do a lot of that testing on a daily basis out there in the market. So it's important we know what it is when we're measuring it, how it applies to the process. And so I hope we've been able to answer some of your questions as we've gone through this series of videos and tutorials on brightness. If you have questions, if you want any further clarification, do not hesitate to contact us. We love working with our customers to help you make better paper. Thanks for watching.